No, look back at your notes from last week. It makes a U or a no, it never makes a B. A function with a degree of 2, take a point. So it makes a U or a what? A mountain. A U or a mountain. When does it make a U? When x squared is what? Positive. When does it make a mountain? Negative. Good. What is the parent? If you can tell me the parent function, you can get a point.
Maximum and minimum. The parent function.
Y equals x squared. Take a point.
Axis and equation.
No. No, an equation is not the parent function. This is a specific quadratic. This y equals x squared is the parent function. Now, what we're going to be doing today is we're going to be using a quadratic when it's in standard form, which is y equals ax squared plus bx plus c. And we're going to talk about how we use those parts to find our specific specific things that we're looking for. Now, we've already defined the word parabola last week. Who can tell me what a parabola is? The graph of a quadratic. Graph of a quadratic. Take a point. All right, it's the graph of a quadratic function. And it can open how many ways? 2. What or what?
Up or down.
Up or down. When does it open up?
When it's up.
When it's x squared. When does it open down? Negative x squared. Yeah, y'all get a point over there. That's going to drive me insane. What does the word symmetry mean? And do not say symmetric. You cannot use a word to define a word.
It's when one side is the exact same as the other.
One side is the exact same as the other. Take a point. Now your axis of symmetry is where it cuts the parabola in half. So, look at these parabolas that we did last week. How would we cut that parabola in half? Would we cut it in half vertically or horizontally?
Oh, vertically.
I said that. I should take
Vertically. And which axis does it pass through? The x-axis. And with that question in mind, does it pass through our vertex or does it pass through a different coordinate?
Our vertex.
It passes through our vertex. So the axis of symmetry is a vertical line that cuts the parabola in half. Now, since we said it passes through the x-axis, you use a formula to find it. X equals the opposite of b divided by 2 times a. And those numbers are when it's in standard form, like we did last week where we had x squared plus 4x plus 3 and we graphed that using a t-table. You can find your axis of symmetry using that. Super easy. What is the vertex? The highest or lowest point on a graph. Thank you, Ashlyn, for sounding like a zombie.
Take a point.
Yes. All right, so it's the highest or lowest point on a graph. And since the axis of symmetry passes through it, the axis of symmetry is the x value of your vertex. So how would you find your y value? Think about what we did last week. How did we find our y values for anything? You plug it in. Good. Take a point. All right, so plug in AOS to get y value. Someone help them out and say it loud. Thank you. Yes, take a point. For being able to figure out context clues. Alright, are we ready or do we need a mo?
Okay,
Can I move my hand?
I don't want to say it because it kind of sounded rude.
Are you guys saying
Oh, yeah.
Oh my god.
Oh yeah, I do have manners.
pre-AP?
Oh, and you can't talk. Okay, son, you do have manners, but it's the listening. Alright, now, what is a y-intercept? When it crosses the y-axis. Good. No. When the parabola, and remember, it's not parabola, it's not a disease, crosses the y-axis. And when it's in standard form, you can find it by just looking at your words equation. So if I give it to you, ham sandwich, children, if I give you the quadratic that looks like this, your y-intercept is C. So it's the constant. Every single time. Right fast, I can flip back. What? Okay. He at least said that right.
Yes, I know.
Okay, now look at this one. What is our y-intercept?
5.
Why is it 5?
Because when the parabola crosses the y,
Yes, baby, but we looked at the equation.
yeah, I know. It's like the same place as C was.
Because it's the C. Thank you so much. Take a point.
Yeah.
You were getting there.
No, I know. I said it. Like,
What does x equal on our y-intercept?
A lot.
X. C. X. The root.
No. This is our y-intercept is at 5, right? So find in your table right here where y equals 5. It's 0. So what is x when you have a y-intercept?
Solution. 0. I thought this was 0.
So the coordinate is 0, C.
Take a point.
I don't know if we deserve a point on that one.
That was all C.
All right, x-intercepts or roots. Can anybody tell me what those are? Oh, we should be able to tell me that. So those of us saying no need to think back what we did last week. Zach, tell me. No. You're close. You're trying to get there. Look at you using your notes. Take a point. When the graph crosses the x-axis.
Yeah, technically he was wrong.
He said when the y-intercept x equals 0. That's not, no. And close only counts in horseshoes and hand grenades. When the graph crosses the x-axis, what else is it called besides x-intercepts and roots?
Oh, 0.
Zeros and solutions. Both of you take a point. And what does y equal on your x-intercepts? 0. How many different types of x-intercepts can we have?
As many as the grade hold.
No.
1, 0, 1, 2.
0, 1, or 2. Can have, y'all do know that Mark doesn't give out the points, right? That I do?
No, yeah, I was waiting for
Okay.
Take a point.
I'm just making sure we remember that.
That's why I didn't put anything on the table.
Alright, what is a maximum? Alright, Aldo.
Isn't that like the highest point on your little view?
The highest point on your,
Your graph thing?
when it looks like a,
Mountain.
When I'm
he's telling me.
a mountain.
A mountain, yes, take a point. So the highest point, sorry, when the graph opens which way?
Or down.
Down. So what does x squared have to be for you to have a maximum? No, when it opens down, what is x squared?
Negative.
Negative. Good. Take a point. X squared is negative. Do we need to draw a picture, or can you understand that? Are we sure? Can you tell me the minimum? Avery is going to tell me the minimum. Yeah.
Okay, it's the lowest point on the U. When your graph looks like a U.
Okay, so the lowest point when the graph opens which way? Okay, take a point. What does x squared have to be for it to open up? Positive. Oh, and we're probably going to the bell today, so I'm real sorry. Yeah. We need to be able to get all of our stuff done today. Alright, domain is the same thing as it's always been, even when we had a linear graph. So what is domain? All the x values. Take a point.
The range is all the y values.
Look at you go. But this time the range is ooh, Blair. It's a specific set of numbers. So the domain are all x values. And what do we call the x values? Is it the input or the output? Input, because we plug those in. And no. And when you're graphing a quadratic, you can plug in any x value in the entire world. So it's all real numbers. And we have a fancy symbol for that. It looks like these.
I know how to do it. You got to. It's not like an R.
No, that's the A and then the R is on the A.
No, that's
Can
it.
you draw it one more time? That's an
R.
It's an R with a line through it.
So.
Oh, because it makes an A.
Oh, yeah.
And then the,
There is a.
how,
Where do you see it?
What A?
Oh,
I
yeah,
see the A.
He's saying that this is the A.
That's the A right there.
Yeah.
That's an H.
So all and then real.
T-H-A-R.
No, it's just an R.
Oh my gosh. Okay, guys.
All
Alright, now your range is what? If domain is the x values are all the
certain set of numbers. All Y.
it's the y values, but this time it's just oh, Blair. It's your output. And it's a specific set of numbers. Specific set of numbers. Do I need to move it up? You think it's funny when I stutter? No. I probably will in a minute. So. What? I'm so glad that's on the video. I'm also very glad for that. All right, are we ready?
No.
Ham sandwich.
What are you doing?
Can you use your hand?
Why are you dropping so much stuff?
Can you not hold? Okay, I'm done.
I'm not.
What are you doing? Are we ready now?
Yes.
Go to the next page. It's really easy. Alright, so the directions say, identify the parts of each quadratic using the keywords from the previous page. Now, I know you can't see the lines that well on the first one, so we're going to kind of guesstimate together. Now, your axis of symmetry is one number, and it passes through which axis? The X. It doesn't pass through your mama. Alright, so this right here is 1 and this is 2. So where do we think our axis of symmetry is?
3.
It's in the middle.
One and a half.
Oh,
This is the coordinates. These are the lines. I'm just redrawing it for us. Oh my gosh.
Take that from me.
This is how... Let's not say it so violently. And that's how you draw an axis of symmetry. Because it cuts the parabola in half. So if you took this parabola and folded it up this way, it would be the same on both sides.
You have to draw the road.
Yes, it's not a road.
You don't have to draw the blue. Draw the pink. So x equals 1.5. You don't have to draw the blue because I was just making the coordinate lines darker. Sweet baby Jesus in heaven.
wait, is he still saying that?
I'm so tired of y'all. Woo.
Please shut your mouth. He's a vertical.
Oh, wait.
All right, vertex. Now the vertex is the x value of your axis of symmetry, and then what is this coordinate? Because it's this point right here. So who can figure out what that coordinate is?
It's like a -7.
1, -7.
1, 2, 3, 4. Thank you, Aldo. Take a point.
Good job, Mark.
Now, these two numbers are going to be the same every single time. Every single time, those are going to be the same. Every single time.
Every
value.
single freaking one.
Whoa.
No,
All right, what's our y-intercept?
-4.
No.
It's wouldn't it be? -3. No.
Yeah, -3.
Take a point out here. Tyler, take one.
No.
Jeez.
Everybody be the kid.
You're saying it so angrily. No.
I'm thinking with the
What?
urgency. I'm thinking with urgency.
All right, so what do you think this point is? Those are our x-intercepts. -2, 0, and
Or +4.
I'm going to go with 4, 0.
Where are we getting these?
We're right
Look
here.
on our graph.
We're looking on our graph.
Oh, shoot.
Okay, so a fun fact right here is your coordinates are going to be the same distance away from your axis of symmetry. So this is 1.5. How many units would it take us to get to 2? Or to -2?
A half. You said out.
We're trying to get to -2.
-2.
Okay, this is at 1.5. So we would go a half and then 1, 2, 3, right? So how many units? We need to go 3.5 to get here. So half, 1, 2, what would that be?
3.
Would it be 5 or would it be 4?
4.
Okay. All right, Max, I can't. Like, y'all aren't listening anymore, and it's going to make me angry, and then you're going to get upset that you don't know what's on your homework, and you don't know how to do your homework, and then you're going to fail your test again. So be quiet and pay attention. It's April. You have 5 weeks left in this school year to bring your grade up. Either get it together or fail. Do you understand me? Is this a maximum or minimum? This is not my happy face. What is your domain always going to be?
You're at.
What did we just say?
It's always going to say so.
Which is, what did we say it was going to be?
All
All real numbers.
Do we need to write this in book or we should already?
That's an 8.
Can you pay attention? Can you pay attention? Thank you. Now, your domain are specific y values. Now, it's y values that are on this parabola. Are the y values increasing or decreasing? I'm going to go with they're increasing, that they're going up from this point. So it's going to be greater than this point right here. So what is this y value? -4. The y value. The y value. So the way you write it is y when y is greater than or equal to -4. We have done this before. Y when y is greater than or equal to -4. And your vertex y value and your range will always be the same. Always be the same.
Vertex and
Yes.
So we always read it to left to right, never right to left.
When do you ever read right to left?
Yeah, in China they do that.
Are we in China?
I bet there's something.
All right, let's look at the next part. Steven, what's the axis of symmetry for this problem?
-1/8.
What is the axis of symmetry?
-1.
All right. X equals -1. Take a point. Jahir, what is our vertex?
So first it's going to be -1 and -8.
That's positive.
Oh, positive 8, my bad.
Okay, honey. Do you see how we go left 1 and up 8 to get to this highest point right there? Okay. Can you tell me what the y-intercept is?
Oh, I got it.
Yes. No, he's going to tell me what the y-intercept is.
You got it.
So you should be able to look at the graph or look back at your notes and figure out what it is without anyone whispering it at him.
0, 6.
Look at you go. Belle, tell me one of the x-intercepts. Opposite way. -3, 0. Rosie, tell me the other x-intercept. 1, 0. Good. Mark, tell me maximum or minimum. Aaron, what's our domain? And what's our range? Who thinks they can do the range?
It's y when y is less than or equal to 8.
Awesome. Take a point. Good job. Is that what you had, honey? Is that what you had?
No, but I had it in my brain.
That's what I'm.
So you had-
Is that what you were gonna say?
Yeah.
Okay. All right. Get out your homework sheets that I put on your desk. You have 2 of them. Now the first one says, for each graph, identify the vertex, axis of symmetry, domain, and range. This is how I want you to write it on your paper each time. I want you to write V for vertex. I want you to write axis of symmetry, which is AOS. I want you to write D for domain, R for range. Yes.
Our table didn't get those.
Yes, you did.
None of us have them.
I walked around and put them on your desk.
And I put that on the wall.
Are you sure? Can we check again and make sure? And look under your stuff?
We only have 3 things.
Okay. What, honey?
Oh, when you're doing
You got to tell me fast.
when you're doing the range, will it always be greater than or equal to and less than or equal to?
Yes, if it's greater than if it opens up,
Yeah.
right?
Yeah.
And then it's less than or equal to if it opens down.
Oh, alright.
All right, now, what is your vertex of this graph? 0, 0. What's your axis of symmetry?
0.
X equals 0. What's your domain?
R numbers.
And what's your range?
Y. When Y is less, that's greater than or equal to 0.
Good. All right, look at the back of this page. What does it ask you to do for these instructions?
Identify the minimum and maximum value.
All right. Is this a minimum or maximum for number 1? And what is the minimum?
Negative.
-3,
0.
1, because it goes up 1. All right, and the last page. Find the zeros for the equation of the oh, Blair. What's one of your zeros? No. 2, 0. What's the other one? 4, 0. That's how you need to write those. Does everybody understand?
Mine's not the same.
Do not come in here without the. There's 2 pages. What on
Can you go back to
this one?
Oh, we have 1 minute. Can we go back to the first one? So you can possibly.